All right, everybody, here is our plan for the day. So here's our midterm review. We've had this packet for a few weeks now, and everything in this packet should be complete except for linear equations. So if you're going through this packet and you're looking at all the pages, everything in here should be complete. If it's not complete, what I need you to do is complete the problems that are missing. So if you were absent a day and you didn't get this page because maybe you were not here or whatever the case is, all of the pages up to this point should be complete. So these are the last two pages we worked on in this packet: domain, range, functions, function notations, and so on. So this is the last thing. Right here at this page, I'm sorry the pages aren't numbered, but this is where we should be beginning today. What we will be working on today is completing the rest of the problems in this packet, starting right here with slope. I thought it would be helpful for me to make a video to show you exactly what pages I'm talking about, and also because there are some notes in here that you're going to want to write in before you complete the problems. So we already know there are 4 types of slope. To look at the 4 types, let's sketch the graphs, what they would look like. So here's an x and y axis, and we know positive slopes are increasing from left to right. So this would be an example of a line that has positive slope. Negative is the opposite. So the line from left to right is going to be going down. This would be a negative slope. If we have a line that's not increasing or decreasing, it stays flat, this has a slope of 0. And if we have a line that is increasing so much that it's vertical, this is actually considered undefined. Mathematically, it's because the denominator, the run, is 0, and you can't divide by 0. So what you would do in numbers 24 through 27 is use the rise over run formula, and you would just count how much does the line rise up or down versus how much does it run, which I usually go from left to right. The next part is finding the slope given 2 points. Let me remind you, the slope formula is y2 minus y1 over x2 minus x1. So you would use that formula to complete numbers 28 through 31. Moving on to the next page, we have slope-intercept form and standard form. Slope-intercept form, you should know, is y equals mx plus b, where m is your slope and b is your y-intercept. Standard form is ax plus by equals c, where a, b, and c are not anything in particular about the line. You don't have the slope, the y-intercept, the x-intercept, nothing like that when the equation is in standard form. But technically, a, b, and c should be integers, meaning that you should not have any fractions in your equations when they're in standard form, which sometimes is tough because a lot of times we have problems in standard form that deal with real-world examples like money. And in that case, you can have fractions or decimals. But for skill-based questions that say, create the equation of the line in standard form, you should not have any fractions or decimals in your equations. So for 32 and 33, you'll create the equations. They say specifically in slope-intercept form. For 35 through 37, they want you to write the equation in slope-intercept form, then identify the slope and y-intercept. So all of those questions are going to be giving you equations. It looks like they're all in standard form, and you're going to solve them for y to put them in slope-intercept form, and then indicate their slope and y-intercept. The next topic is x and y-intercepts. So to find the x-intercept, we set y equal to 0, and we solve for x. So when your line is on the x-axis, that point, wherever it crosses the x-axis at, is called the x-intercept, and that point always has 0 as the y-coordinate. That's why you replace a 0 in for y, and then you solve for x. Vice versa, to find the y-intercept, if it's not already in slope-intercept form, which I can see one of these equations below, or 2 of them are already in slope-intercept form, so you can see the y-intercept from the start. But if not, then what you do is you set x equal to 0, and you solve for y. That's because when a line is on the y-axis, its x-coordinate is 0. Moving right along. The next page is graphing linear equations. Graphing from slope-intercept form is probably my favorite way to graph equations. We also have learned how to graph them by finding x and y intercepts. But if you don't like finding x and y intercepts and you would prefer to graph them from slope-intercept form, take all of these equations and solve them for y. For number 50 and 51, you're taking these graphs here and figuring out which line best represents the graph. The lines that they give you are all in standard form, the equations, and in standard form you can't see the slope or y-intercept, so I suggest solving those for y to figure out which one has the correct y-intercept and the correct slope for those lines. All right, moving on to point slope form. So when a given point x1, y1, and the slope m is given, use point slope formula, which is y minus y1 equals m times x minus x1. For these questions, they say write a linear equation in slope-intercept form given the point and the slope. My suggestion here would be to first create your equation in point slope form. So for number 1, y minus 7 equals 3 times x minus 2 could be your beginning equation, and then take those equations and solve them for y, and you would get your equation in slope-intercept form when you do it that way. If not, then what you would have to do is create your equation like this, y equals 3x plus b, and replace in this case, 7 for y and 2 for x, and figure out what b would have to equal, which is your y-intercept. In this case, 7 equals 6 plus what? Well, it would be 1, since 6 plus 1 is 7, so that's how you can get it that way as well. The next section is giving, you're going to have 2 points, and they want you to create an equation using those 2 points. So your first step for this would be to use the slope formula, which is m equals y2 minus y1 over x2 minus x1. Once you find your slope, you then use that slope, and you can either put it right into slope-intercept form if you would prefer to just use a point and solve for b, or you can take that slope, use point slope form, which is y minus y1 equals m times x minus x1, and then you can solve that equation for y, and you would get your final answer in slope-intercept form. We have many different ways we can arrive at the same answer, but your final answer for these questions should be in slope-intercept form, which is super important to be able to read the question and know what form your final answer needs to be in, or else it would be considered incorrect. And then the last page of questions, when given 2 points, use the slope formula followed by point slope formula. Again, this is kind of like the same exact thing as the previous page, but the slope formula is y2 minus y1 over x2 minus x1, which is good practice, helping you remember these formulas. Even though they will be on the formula sheet for the midterm, it is helpful to have them memorized. And then here is our point slope formula again. Same type of thing for these two. You're going to be doing the same process. And then for the last 2 topics. Topic 12, parallel and perpendicular lines. So remember, parallel lines have equal slopes. So the slopes of parallel lines are equal. For example, y equals 2x minus 1, y equals 2x plus 4. They have the same slope. They're parallel lines. But perpendicular lines, they have opposite reciprocal slopes. For example, y equals, let's say, 1/3 x plus 2. This one has a slope of positive 1/3. The slope that is an opposite reciprocal of positive 1/3 would be negative 3/1. So y equals negative 3x, let's say minus 8, the y-intercept doesn't matter, it's all about the slope. So for these questions, you're going to be creating equations of lines that are in different forms that are parallel or perpendicular to other lines. And then the last topic is looking at which scatter plot would have the line of best fit close to y equals 2x plus 1. When we come back on Monday, I will be checking that this entire packet is complete from start to finish. It's a 20-point assignment, so it's worth a lot of points. So please make sure you're using today and the weekend to complete all of these problems in preparation for the 20-point completion assignment and in preparation for the midterm. Please email me if you have any questions or concerns.